All right, so we're gonna graph together r sine of theta is equal to 2. So it's been a couple days, but what we want to try to do to kind of better understand what's happening here is rewrite this in a way that makes more sense to us. So what I'm looking at, and this is jumping out to me, is this right here. Do we have any other way to write this? Y. Good. This is the same thing as y. So I could rewrite this whole function as just y is equal to 2. So just based off what you guys know, don't disappoint me right now. What does the graph of y equals 2 look like? No. Like this. It's linear going this way. And the way that you guys can think about it is if I have my graph, right? Which axis is y? This one or this one? The up and down, right? So if y is always 2, that means the line has to go this way. So that way y is always 2, okay? That's the way I remember it. So what I want you guys to visualize is this graph is a little bit different, right? Because it's polar. So if you guys look at our regular graph, do you guys see how we went up to get to 2? So from here, what I'm going to do is if I go up 2 in quotes on the polar graph, I'm going up like 1 or 2 circles. So what I'm going to do is I'm going to plot a point right there. And then I'm going to draw a straight line through that point. So what I'm going to do is using a ruler, I would graph a line that goes like that. So this is just a horizontal line, 2 units above the center, guys, we call the pole. Okay, we have one more of these very simple ones before things get a little bit more crazy. Questions on this example? All right, so next example, I want us to identify and graph r cosine theta is equal to -3. Okay, so same idea, guys. Is there another way I could write this? Yeah, this, remember, is just x. So I can just rewrite this equation as x is equal to -3. So what does that look like on the xy plane? It goes up and down, right? So which direction from the pole am I going to move? Left. Good. Because x is equals to -3, do you guys agree, is to the left of the center? So the same idea, I'm going to go out 1, 2, 3 radius lengths and plot a point from the center. So I'm going to draw a point right here. And then I'm just going to draw a vertical line that goes through that point. So this is the equation, x equals -3. So I'm going to describe this as a vertical line. Three units left of the pole. Okay, do you guys have questions for me? Does this make sense? Now, Unfortunately, it's not always going to be that simple. Okay? So what we're going to see now is what happens when things get a little bit more crazy. So if you guys can do me a favor, you guys should have this box. Go ahead and tape this in. So all this is, guys, is a summary of what we basically just saw in these notes so far. So this right here was example 1. This was example 2. Example 3. And example 4. Okay. I'm not going to give you guys a test question on stuff like this, but this is just like a way that you guys can identify it. So if you guys are working on your assignment, have I given you guys 5.2 yet? The homework? I have copies of it, I just haven't handed it out yet. But when you guys are doing your assignment, this is kind of how you can identify what those easy ones look like. So that way you guys know if you're on the right track or not. Okay. So now, let's look at ones that are a little bit more complicated. So I want us to graph trying to see if this will, no. No? That's weird. Okay. So what does this look like? Well, we're going to be creative here. Because we have a way to convert this into rectangular coordinates, because we had a definition not with r, but with r squared, okay? So if I want this to become r squared, what do I need to do to this so it becomes r squared? But what do I need to do to change it to r squared? Multiply by r. But if I multiply this side by r, I have to multiply this side by r2. So then I get r squared is equal to, this becomes 4r sine theta. And this is helpful because this right here is x squared plus y squared from section 5.1. And then just from the last couple examples, guys, what is this? What? It's just y, right? So this is just for y. So spoiler alert, you guys probably already know what's going to happen. But what I need to do is I need to complete the square. So I need to move this term to this side and complete the square. So x squared plus y squared, I'm going to subtract the 4y to this side and leave some space. So if I move it over, it's going to be equal to 0. To complete the square, guys, remember I need to take this value and do what to it? Divide by 2. So b is equal to -4. If I cut that in half, that's going to be -2. And then remember we have to square it. So it becomes +4. So I'm going to add 4 here and then add 4 over here. Using my work I've done, I can rewrite this as x squared plus, remember you guys can factor it now. Which number am I going to use in the parentheses? -2. So it's going to be y minus 2 squared is equal to 4. So this is my equation of my circle. So this is a circle. What's my center? 0, 2. And what's the radius? Good. The radius is 2. So we don't need to graph this in a crazy polar way. All we have to do is think about how would I get here on this graph? Well, which direction would I have to move? Up. So I'm going to go up 2. So up 2 radius lengths. And then what's my radius? 2. So I'm going to go down 2, up 2, and then I'm going to try to go to the right and left 2 about the same distance. So I'm going to kind of guess what that would look like. And that's even off. So I'm going to try it again. Maybe something like that. And then try to draw a circle through those 4 points. It's not going to be perfect, and that's okay. But please don't give me like some trash looking circle like that. That's not a circle. Okay. Questions? All right, let's do one more like this. Okay, what could I do to kind of do something similar here? Multiply both sides by r, good. So if r is equal to -2 cosine theta, I need to multiply both sides by r first to get r squared is equal to -2r cosine theta. What is this the same as, guys? X squared plus y squared. And then I can change this to -2x, good. Now, same idea, I'm gonna complete the square, so I need to move this term to this side. So I'm gonna get x squared plus 2x, and I'm gonna leave some space, plus y squared. See how there's no other y term, guys? It's just y squared. I don't need to leave space then, because there's nothing to complete the square on for the y. And if I move the 2x to the other side, that means I have a 0 over here. Okay, so my b is 2. Cut in half, you get 1. Square it, you still get 1. So that means I'm going to add 1 right here, which means I need to add 1 over here. So using my work, I can rewrite this as x plus 1 squared plus y squared, and that's equal to 1. Okay, so what's my center? Say again. -1 comma 0. And what's my radius? 1. Good. So we know this is a circle. It's my equation. This is a circle. So to get here, do you guys agree I need to move to the left of the pole? So I'm going to draw a point right here and then go to the left 1, because that's my radius, to the right 1, down 1. I'm just going to kind of guess what that would look like. Maybe like something like that. And then up 1, same thing. I'm going to kind of guess what that would look like. Maybe something like that. And so I have my circle. Okay, so here comes the cool part. You guys ready? We can do this on our calculator. So this is what I want you guys to do. On your calculator, there's a couple things you have to do in order to graph this on your calculator. First thing you're going to do is you're going to go to mode. And this is really important. You don't forget about this tomorrow, because what mode should your calculator be in tomorrow? Degrees. You have to switch it out. Otherwise, you're going to get horrible answers tomorrow and everything's going to be wrong. Okay, so don't forget. All right, so you're going to go to mode. What type of functions are we graphing? It's a circle, but what's this section called? Graphing what? Polar. Do you guys see how there's a polar mode? Scroll over to polar and hit enter on your calculator. Second quit. Now check this out. When you go to y equals, Now it says R equals. What was our equation? -2 cosine theta, right? Now, what's cool is when you go to type in X, what does your calculator give you now instead? Theta. Isn't that cool? And then hit graph, and what type of function does it give you? Didn't do it? Let me see. Hit graph. Did you do polar mode? Does anybody not see that? I know it looks like an oval, but it's supposed to be a circle. No? Can you reset your calculator? Go to second memory. And then reset. It might be your window then. Go to zoom 6. Zoom 6. You can just hit 6 on your keypad. That's why I said 6. There you go. All those buttons, you can just hit 1 or 3 and it'll access those shortcuts. Okay, cool guys. So now that our calculator's in polar mode, we're gonna be able to do some more things. So again, we have a circular polar graph summary. So if you guys can just tape this in and then we'll move on. So now for the rest of this lesson, these are gonna get a lot more complicated. So we need to do what's called symmetry tests to figure out how to sketch this in an efficient way. Because otherwise, I never learned these tests, and I end up having to graph between 0 and 360 degrees for every problem, which meant I was making a table of like 20 points. And you guys are welcome to do that if you guys want to. It'll only take you guys like 30 minutes to do every problem. Okay, so I want you guys to tape in this box. You guys do need to know these rules when you guys take your chapter 5 test. Okay, so the first test that we're going to do is called symmetry with respect to the polar axis, which in our case is called the x-axis. So in order to do this, if you guys can highlight this, replace theta with negative theta. If an equivalent equation exists, then the graph is symmetric with respect to the polar axis. And I'll teach you guys what that means in terms of our table. I want you guys to understand that all of these tests make it so your life is easier when it comes to making your table. So it's going to seem at first like, wow, this is a lot of work, but you're saving yourself work later by doing these tests, okay? If it's symmetric with respect to the line, theta is equal to pi over 2. Replace theta with pi minus theta. And then same thing, if an equivalent equation exists, the graph is symmetric with respect to the line, theta is equal to pi over 2. And understand that theta equals pi over 2 is basically like the y-axis. Okay, last one, symmetric with respect to the pole. Replace r with negative r, or theta with negative theta plus pi. If an equivalent equation exists, then the graph is symmetric with respect to the pole. So what's nice about this is both tests have to work in order for this one to work. I'll say that again. Both tests have to work in order for this one to work. If one of these fails, you don't have to do this test. Okay, and I'm recording this so that way if you guys are doing your homework, you need to go back and see this. So it will save yourself work. Like if test 1 fails, that means that test 3 will automatically fail because this one takes a lot of work, okay? So I'm trying to make your lives easier. Okay, so knowing that, you guys have this in your notes or no? Just tape it in. All right. So we're going to do this one together, and then we'll see how much time we have left because this first one's going to take us the longest just because it's the first time you guys have seen it. So what I want you guys to do is don't tape in a graph yet because we have to do all the symmetry tests first in order to even make a table. So if you guys look at my notes, check it out. I have an entire page so that way we can do all the steps before we can even graph it, okay? Oh, you have no more graphs? Well, that's crazy because I have more graphs. Just cut out one for now, guys. Don't like cut out all six. All right. So the first one we're going to graph, doing all these crazy rules, is R is equal to 1 minus the sine of theta. So like I said, we need to do all of these symmetry tests to make our life easier. So if I look at my notes, what is the first symmetry test? What are we testing for? But what's the test called? Testing for polar axis symmetry. So it basically means, guys, if you guys can turn and look at me, if I know what the top half of the graph looks like, the polar axis is like the x-axis. So basically that means I can just take the top half and fold it across. So that way I'm only graphing like one thing and it's flipping it over. So then I'll have to do it twice, okay? So the rule for that, according to our notes, is to replace theta with negative theta, okay? So this is going to require us to remember something about trig functions, so pay attention. R is equal to 1 minus the sine. All I'm doing is taking theta and replacing it with negative theta. Now, what do we know about sine and even and oddness? Is sine even or odd? Sine is odd. So this means the sine of negative theta is equal to negative sine of theta. Right? You guys with me on that? Does that sound familiar? Hopefully. Okay, so if I know that, that means that I'm going to plug this in right here. But do you guys see how there's already a minus right here? What's going to happen to the double negative? It becomes a positive, right? So it becomes 1 plus the sine of theta. So this is what you need to do now. Compare what I wrote in black right here. Is this the same as what I started with? So since it's not the same, that means the graph is not symmetric with respect to the polar axis. So therefore, our graph is not symmetric with respect to the polar axis. So our test failed. Okay, well that sucks. Now we gotta try a new test. So test 2. Let's test for symmetry across the line, theta is equal to pi over 2. Now I'm going to be honest, guys. This one is the most annoying for us to do. You guys ready? So what does our note say to do this test? What do I need to replace? Yes, pi minus theta. Okay? So this becomes r equals 1 minus the sine of, instead of theta, I'm going to write pi minus theta. Hey guys, don't we have a formula for this? Sine of alpha minus beta is sine of alpha cosine beta minus sine of beta cosine alpha. You have to know that formula for these notes, for this section, okay? So this becomes my alpha, this becomes my beta. So this becomes 1 minus, I'm going to put all of this garbage in parentheses. So it's going to become sine of pi cosine theta minus cosine pi sine theta. Now, if you're wondering, okay, well, if I want the formula to be the same, I don't want cosine thetas, right? Because is there a cosine theta in my original equation? No. But what's nice about this is, check it out. What is the sine of pi? 0. So 0 times this, what happens to that? It's gone. Okay. What is the cosine of pi? -1. So this becomes just, this right here is just -1 sine theta. And then since I have a negative here, this becomes positive. So this just becomes 1 minus 0 plus sine theta. And if I simplify that, what do I get? Hey. So does our test pass? Hooray, it does. I am not trying to make your lives more difficult. One of the tests should always work. Either the first one or the second one or all three. So, therefore, this graph is symmetric across the line theta is equal to pi over 2. So I'm going to put a check mark. And we're not even going to finish this because we're going to run out of time. All right. So if you guys are listening, do I need to do the third test? Why? The first one failed. If one of them fails, the third one will fail. That's what I've just noticed. I'm not an expert on this yet. Don't yell at me. This is my year 2 of teaching pre-cal. But I noticed that every time one of them failed, the third one failed. So because of that, I'm not going to give you guys problems where all of a sudden, oh, it does pass. Woo! No. So the third one fails too. So since test 1 failed, test 3 will also fail. Okay. Now here comes the cool part. How do I graph this? So this is what I want us to do. So we're not going to do an X and Y table. We're going to do a theta and R table. I honestly, I do want to finish this before you guys go, so hopefully we can. Do you think we can do it? We can do it. You have faith? I have faith. Okay, where is theta equals pi over 2 on the unit circle? Where's pi over 2? What? 90 degrees, right? So which direction do I move from the center? Up. So if pi over 2 is right here, if this graph is symmetric across this line, what I want you guys to do is just draw a line that goes through the middle of the graph. That means if I know what the graph looks like over here, all I have to do is just copy it and reflect it to get that graph. So if I'm making points in my table, guys, I just need to pick angles that are to the right of this line, and then I can reflect them across to get the other half of the graph. Does that make sense? So to make my life easier, what I'm gonna have you guys do is we're gonna pick angles that are over here and then reflect them across. So what I want us to do is, remember, do I pick like those angles? Remember? No. So I'm gonna pick, and here's the cool part. You guys can use degrees for this because we're gonna use our calculator. So I'm gonna do 30 degrees, 45 degrees, 60 degrees. And then I'm also gonna pick 330 degrees, 315 degrees, 300 degrees, and then down here would be 270 degrees. And then you guys agree this would be 90 at the top, right? All right, so what I want you guys to do is in your calculator in Y1, type in 1 minus sine theta, and then go second table settings, because we're gonna change our table settings right now. Do you guys all know what I'm talking about when I say that? Of course it locked me out. Why would it keep me in? Okay. So make sure it's in polar mode for all our audience at home. 1 minus sine theta. Okay, go to second table settings. And then what I want you guys to do is right here where it says independent, that's your X's. I want you guys to change it to ask, because then you're allowed to pick whatever the heck you want. Okay, because otherwise you're gonna have to scroll to find the X's that you're plugging in. Okay, so then when you go to your table, all you have to do now is plug in the numbers that you chose. See if it does it. Does it do it? Oh, it does. Sweet. Can you guys see that? So I want 270, 300, 315, 330, 0. I should have wrote 0. Oh, it doesn't do it. Come on, come over here. There we go. So 270, 300, 315, 330, 0, and then 30, 45, 60, 90. And then these are all my values I'm going to copy into my table. Do you guys see how I got those? I just typed them in, just hit enter. So 270 is about 1.18. 300 degrees, 1.999. Do you guys agree that's about 2? 315 is 0.255. 330 gave us 1.13. 0 gave us 1. That's nice. And then 30 gave us about 2. 1.98. 8. 45 is small. 0.15. I'm going to write. 60 degrees. 1.3-ish. And then 90 degrees is really small, 0.106. Okay, so what this means, guys, before you guys leave, and we'll wrap this up in a little bit better way on Wednesday, tomorrow after your test. But what I'm going to do is, these are all radiuses, right? So all I'm going to do is at 270 degrees, I'm going to try to draw a radius that's a little bit bigger than 1. So something like where that blue point is. Okay, and then do the same thing for all of them. Once I have my points, I can then reflect them across. And here's the cool part. I know some of you guys want to go into the health field. What does this prefix mean? Cardio. What does that mean? Heart. This graph is a heart when you graph it. That's what this means. A cardioid is a heart-shaped graph. Okay? So we'll graph it tomorrow after your test.